vertex, the focus, and the axis of symmetry. And another thing, something that I forgot to mention on when I had the drawing, the colorful drawing of the parabola, the focus, and the directrix. Something that I forgot to mention is that the distance from the focus to the curve, which is the parabola, is always going to be equal to the distance from the directrix to that same point. So the distance from here to here is going to be the same distance from here to here. It always has to be the same distance. Now, we're missing something else in here. And what we are missing is going to be the lattice rectum. Lattice rectum. So it's going to be this line right here, as I mentioned over there. So from there to there. And I know this is a little bit confusing and more because I am drawing everything in a very clustered pace. But okay, the distance from this point to this point is always going to be 1/8. And just as we did over here, we get 8 from here. So it's going to be 1/8. Let's pretend that this is going to be 8. So it's going to be the distance from here to here, it's going to be 1/8. And let's pretend that it's 1/8. So it's going to be 1/1/8, so that this is going to be 8. And something else. When this is negative, it goes up or down or left or right. But when the variable, if it's a big variable like 100, then the parabola is going to be very, 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 very narrow. And if it's a very small variable, such as 0.25, then the parabola is going to be more open. So the distance from here to here is going to be, if this is 8, it's going to be, the distance is going to be 1/8, so it's going to be smaller. Now if the distance is 1/8, it's going to be bigger, so it's going to be 1/1/8, which would be 8. So that's why the distance changes opposite sides. If it's a big number, it's very small. If it's a small number, it's very big. And another thing, so we are now finished with the parabola being drawn this way. In order to avoid more confusion, I'm just gonna explain the other one right here. So let's pretend that we have y equals -a of x minus h squared plus k. If we have a parabola that, like this, it's going to be exactly the same thing for everything, except that we are going to have the parabola looking down. The vertex is going to be exactly the same. It's going to be right here, because we mentioned that we're gonna pretend that h is 0 and k is 0. So h, k, 0, 0. And the vertex stays like that. So for the axis of symmetry, we gotta set this equal to 0 so that we can derive the axis of symmetry from this part. And x minus 0 equals 0, so 0 minus 0 is equal to 0. And the axis of symmetry is going to be at x equals 0. It's going to stay exactly the same. So axis of symmetry is also going to be equal to 0. Now for the focus, that's where it changes a little bit, because we're going to stay with h as well. The focus is going to be somewhere over here, because since it's opening down, and the focus has to be in the inside the parabola, we're going to stay with h, k. But now instead of adding to k, we're going to subtract to k from k. And as I mentioned previously, k, to find the focus, we're going to add or subtract 1/4a. And in here, we are going to subtract 1 over 4a, which is going to be h. Okay, the focus is going to be equal to h k minus 1 over 4a. 1 over 4a. And for the directrix, we're going to do the opposite, because this time we're going to have to add in order to get it. We're going to stay with h, but k is going to change. So this point is going to be h k plus 1 over 4a. So for the focus, no, directrix, the directrix, not the focus, not a point, it's a line. For the directrix, it's going to be equal to h k plus 1 over 4a. And we're going to get our a from over here. Now the latus rectus is going to be the same. The distance from here to here is going to be 1 over 8, not 8. 1 over 8. So, as you can see right here, it's the same exact thing, with the difference that these two change. And the reason why these two change is because a positive times a negative, it's a negative. So that's why this one is becoming a negative, because it's h k plus 1 over negative 4a. So you just need the positive, and it's minus 4a. And for this one is h k minus 1 over negative 4a, because it's negative, so you're going to delete them, and it's going to be positive. So that's why. So now, in the previous one, I did it with y equals, and I did it with by squaring the x. So it was one that was going up and was going down. Now this time we're going to square y. X equals to a, in parentheses, y minus k squared plus h. So once again, the vertex is going to be at the origin. In order to complicate it a little bit less. I know that it's already somewhat complicated, so let's keep it there. The vertex is going to be at 0, 0, which is hk. So since h is going to be 0 and k is going to be 0, x equals to a, y minus k squared plus h. It's going to be, okay, so we have the vertex. Now let's find the focus. Let's find the focus. And we know that the parabola is going to be opening to the left or to the right. Why? Because we're squaring y. We're not squaring x anymore. We're squaring y. So it's going to be opening, since this variable is positive, it's going to open to the positive side. Okay. And another thing that we can find from here, we can derive the axis of symmetry. And we know that the axis of symmetry, y minus 0 equals to 0, and because k is 0 and 0 minus 0 is equal to 0, so y is equal to 0. That's going to be our axis of symmetry. This time it's y equals 0 instead of x equals 0, because y is the one that's being squared. So our axis of symmetry is y equals 0. That's our axis of symmetry. So this time, this is h and this is k. So this time, to find the focus, let me put the focus over here. To find the focus. We are going to, are we going to stay with H or are we going to stay with K? Okay, so obviously we're going to stay with K because K is the y-axis and K is going to be 0. So we're not going to move. We're not going to move We're not going to move from 0, from y equals 0. It's going to stay in y equals 0. So the one that we're going to have to add or subtract is going to be H. So it's going to be, let me skip this part and let me put K, because we're going to stay with K, and we are going to add. So it's going to be H plus 1/4A. So our vertex is going to be the distance from here to here is going to be 1/4A, and for the directrix it's going to be the distance from here to here. The distance from here to here is going to be -1/4A. So the directrix is going to be H minus 1/4A and K. So for the lattice rectum, the distance from here to here is going to be 1/8. So now we're going to grab the same one, but to the opposite side. So this one's going to open, it's going to be the same one. It's going to be, the one that we're going to be squaring is going to be the y-axis, the y-coordinate. So since it's -A, it's going to open to the left side. And the vertex is going to be at 0, 0. This is H, K. It's going to be exactly the same as the other one. The axis of symmetry, we're going to derive it from here. So the axis of symmetry is going to be y minus 0, because K is 0. Y minus 0 is equal to 0. So 0 minus 0 is equal to 0. So y is equal to 0. So the axis of symmetry is going to be y equals to 0. This is y equals to 0. So that's going to be the axis of symmetry. And our graph is going to open to the left because it's a -8. So we already have the axis of symmetry. Axis of symmetry is equal to y equals to 0. Now let's find the directrix. No, the focus. And the focus, as always, it's going to be inside the parabola. So it has to be somewhere inside here. So in order to find the focus, we know that K is equal to 0, and we're not going to move K. We're going to stay in y equals 0. 0 is going to, the one that we're going to be manipulating is going to be H, not K, because we're going to stay in y equals 0. So this one has to be something K. And since we're working on the opposite, to the opposite side, we're going to be working with, it's going to be H again, plus -1/4A, -1/4. And this is pretty much how we graph parabolas. Thank you very much.
All right, this is going to be conic sections, but for ellipse. The conic section definition is an ellipse are a closed type of conic section and have many similarities to the parabola and the hyperbola conic section. The cross section cannot be parallel to the x-axis or the axis of the cone. As you can see here, I drew the way the plane is supposed to cross through the cone. Because if we cross through like this, it will just be a circle. Like this, it's going to end up looking like that. and that's going to be ellipse. Ellipse. All right. So a little background about the ellipse is that it comes back. It was named by a Greek scholar named Apollonius of Perga, and can be translated to mean omission. So I'm going to go ahead and write out the equation for this ellipse. It's going to look a little similar to the circle and the parabola, just a little bit different. It's still going to equal 1, but this time there's going to be a little bit more added to it. And that's going to be your standard equation for the ellipse right there. Let's see. So I'm going to draw this out as best as I can. There you go. On an X and Y axis there for you guys. And basically, let's see. The A is going to be how wide it is. So right here it's A squared. So if we get the value of A, and let's say it's over here, and over here, these are going to be the x's, A, negative A, and this one's going to be A, this is going to be how wide it is, and B is going to be how tall it is. Does that make sense? So B and negative B. So it's going to look a little like this. Almost looks like a circle, but I didn't need to draw it like that. This is going to be negative B. And the way they figure out which one is which is going to be by defining this right here. This is going to be called the major axis. Now the major axis is always going to be the one that's wider. So I know it looks like a circle. I should just redraw this right now. The one that's wider is going to be the major axis, and the one that's smaller is going to be minor axis. Easy peasy. Now, notice that I started from the origin. The origin, which we all know that it's 0, 0. But if we were to start from any other point, then the equation would change. And the equation is going to change looking like this. It's going to be minus k. Sorry for my ugly handwriting. So if it's not at the origin, and if it's at a different point, then it's going to look like this equation. But the h and the k are going to be the origin of the ellipse. And that's pretty much the basic information that you need to know about the ellipse. And thank you. It's going to be conic sections, but for hyperbola. Now, this one's going to be very similar to the ellipse and the parabola, but it's going to be a little bit different. I'm going to talk about the definition actually is an open curve with two branches formed by an intersection of the plane and the double cone. Now, if you were like to open this, you would get something that looks like this. That's the way it's going to look whenever I graph it. So we'll see that right now. And a little back story is the hyperbola is a word meaning overthrown or excessive. And it was first discovered by a mathematician named Menaechmus, around 190 BC. So let me go ahead and start with this. Alright, so the standard equation for a hyperbola is almost exactly the same as an ellipse. It's going to look like this. Over a squared, b squared. The only difference is that instead of a plus, it's going to be a minus. That's the only thing. Graph it, it's going to look something like this. Now, how do I determine whether it looks like this or not? Is by the x and the y. Now, if the x is positive and the y is negative, then it's going to go from side to side on the x-axis. If the y was positive and the x is negative, then it's going to go off the y-axis. So whichever one is greater, that's where the hyperbola is going to be graphed on. But I'm going to stick with this one. That way it won't be too hard. So let me regraph this. So it's going to look like this. Now, So we know that it's going to be going like this from side to side, and the origin is going to be at 0 because there isn't any. This is a standard form. If it was not a standard form, it would look a little bit like this. Over n squared minus 1 b squared. This is not a standard form. This is not at the origin. H and k can be any integers that you would want, and therefore the origin of the hyperbola would therefore be the point of whatever h and k is. But since there's no h and k here, that means that we're starting at 0 and 0, which is right here. 0 and 0. Now, A is going to be how, similar to the ellipse, A is going to be how tall, actually how wide, my bad. It's going to be how wide it is. So from here to here, let's say, let me practice. From here to here is going to be A, and from here to here is going to be B. And this, of course, would be negative A since we're going left, and this, of course, would be negative B. So if you were to kind of box this to where everything is at, you would form a rectangle almost. It looks more like a square, but it should be a rectangle. And with this rectangle, you'll be able to find the asymptotes just by slicing the rectangle diagonally. These two would be your asymptotes. What's an asymptote? An asymptote is a line where the curves do not touch. So that's how you would find that out. And of course, with every conic section that we've had previously, there are foci, or foci, different ways to say that, but to each his own. And there is an equation to find the focus. And it's very similar. It might look pretty familiar for some. Almost looks like a Pythagorean theorem. Actually, it is a Pythagorean theorem. So, but it's also an equation to find the foci. So if you were to plug in A and B, you would be able to find C, and therefore the distance between here to here would be your C. It's negative, it's going left. From here to here would be your positive C. And that's how you'd be able to determine or find out what your focus is. And that's pretty much it for the hyperbola. It's very, very easy once you get the hang of it. And like I said, it's very similar to the ellipse and very similar to the parabola. Just now there's two parabolas. And thank you.
Thank you very much, everybody, for watching this video, and I hope everybody enjoyed it, and hopefully everybody was able to understand what conic section is, and hope that everybody has a good day. Thank you.
Thank you very much.